Welcome. This is the fourth video in this video tutorial series. And in this video, we are going to present one of the key components in any federated learning setup. In Flower, we call strategies the component that orchestrates most of the logic in a federated learning experiment. It is in charge of sampling clients at the beginning of every round, communicating to the clients the global model that they need to train locally, as well as communicating a set of instructions on how to perform this training. We're going to see that in Flower there are a long list of strategies that you can use, and in this case we're going to use Fedaverage. We're going to use this video also to introduce things like how to configure the function that will be executed on the server side when you want to evaluate your global model. At the end of this video, by the end of this video, we would have all the components needed to start our federated learning experiments. So get ready for this. This is going to be an exciting video. Don't forget you can find the source code for this video and all the videos in this tutorial series linked in the video description below. And remember, if you have any questions, feel free to ask us on the Flower Slack. So first things first, I'm going to import Flower. And here we're going to define our strategy. So strategy is going to be flower.server.strategy. And in Flower, there is already a plethora of strategies implemented, and you can pick any of them really for this, even for this experiment. But we are going to stick to the most popular one of them all, which is Fedaverage. And as you can see, there are quite a few arguments you can set in order to parameterize your experiment. Things like fraction fit, which is used to decide how many clients to sample per round, or other arguments like how the server should evaluate a global model, things like that. So we are going to set a few of them, and the first one is going to be none other than fraction fit. So fraction fit follows a logic that is explained here. So the idea is because sometimes not all clients that are out there are really available. You might want to follow, you might want to set different variables like min fit clients instead of only fraction fit clients. But for the purpose of simulation, because realistically all clients are available at all times, even if they are not, instantiated, we're going to set this value to very, very small. I think this is a way that makes it much easier to understand. And when this value is very small, then you can control exactly the number of clients that are going to be sampled by using min fit clients, which we are going to set from the config using and we're going to say num clients per round fit. We're going to give it a very verbose name, but in that way it's going to be quite easy to understand. So let's make sure we have this here. We're going to set it to, let's say, 10 clients per round. Next, there is another equivalent set of arguments called fraction evaluate, which, following the similar logic, you can set to, in order to decide how many clients should be sampled, not for doing local training, but to do local evaluation. So following the same process, I'm going to set it to a very small value because at all points, all clients are potentially available, and they are all available if we decide to use all of them. But we don't want to use all of them, so we're going to set this variable called min evaluate clients, which is going to be set from the config as well. And following the same pattern, we're going to name it num clients per round eval. And let's make sure we don't forget about this. And because the evaluation is much more lightweight than doing training, I'm going to set it to a bigger number, something like, let's say 25. So after every round, if we have 100 clients, a quarter of them are gonna be used to evaluate what's the current state of the global model, which is a very handy thing to have if, for whatever reason, it's not feasible to have a centralized validation set or even a centralized test set, which is actually the case in many real-world settings. Okay, we need to set another variable called mean available clients, which tells the strategy how many clients are going to be in total at any given point in time. And for simulation, we know all of them are going to be available realistically. So we're going to set this to num clients, which, remember, is the same variable we used earlier to specify how many partitions we want to create using our dataset. So this is as far as scalar arguments we're going to set when creating Federates, but all these arguments are optional, but we're going to set 2 additional arguments which specify functions. We're going to give a function to the strategy. And the first function is going to be for this particular argument, which is onFitConfig function. And what does it mean? So every strategy has different methods, and one of the key methods is called configure fit. Actually, let me just we can do it here. Go to definition. We can go to Federates. I'm going to show to you here. So here we're in Federates. Probably some of these arguments already look familiar to you. These are the default values. But if we scroll down, we're going to see that there is a method called configure fit. This method, what it does is it configures how the client is going to do fit. So it will set things like, okay, how do I perform, for example, the sampling of the clients. Here I'm calling the client manager to sample a fraction of clients that are going to be participating in this particular round. So that's decided here. Other things that are configured are the parameters. So the configure fit method receives the parameters from the server and puts them inside a new data structure called fit instructions. And along with the parameters, there is this config variable that might sound familiar, having seen these 2 together, parameters and config. This is something we had here in the fit method of my client, right? Parameters and config. So what the onFitConfig function does is sets this function here, which this is telling us if this is not none, so if we are defining something, call this function and obtain the config. So what we want to do is here we want to create a function that can be called in this way. So a single input argument is going to be the server round, and this function is going to return something which is a Python dictionary. So let's do it just that. And what we're going to return is none other than these variables. All right, so let's see how we can do that. So I'm going to keep these Federates here, because we might look into it a bit later. So how to do that? Let's create a new Python script that we are going to call. Oh no, not here. Let's keep things simple. Let's go here. We're going to call a server.py. And in this function, we are going to create a function that is going to provide these instructions to the strategy that are eventually being sent to the client. And as you are going to notice, we're going to follow a very similar logic as what we did here. In fact, let me put it down here so you can see in a more obvious way the similarities. So we're going to define a function that we're going to call get on fit config, which is going to be called from here. So it's going to receive some input arguments. We'll set them very soon. And then this is going to return as a function called fit config fn that we know it's it's gonna be passed with this input argument. So we better make sure that we are accommodating this argument. So the name is not really important because here we are not using a keyword, but let's just keep the same name. And what we want this function to do is to return us an argument. A dictionary, sorry. So if we were doing something like this, and let's come here and there from server import get onFit config. So if we were doing something like this, what will happen here when we call this, it will be returning this function, a function that looks like that does nothing, just returns an empty dictionary. So the behavior of this logic in the strategy would be basically the same as if we were not doing anything here, right? Because the config here will be this, which is an empty dictionary. But we don't want to do that. We want to be able to configure how the clients do their local training based on things that we, for example, set on the config. So how do we do that? So something we can do is just send this entire config node. So what I can do is I can do config.config_fit. And here what I will get is, let's say, config, and this is going to be of type ticked config. And let me get the right import. And now here, for example, we will be giving everything to the client. So we could access, for example, the learning rate, and we can do it like this. And so on. You could do this for all the arguments. So what else? Local box. Yeah, like that. Or, for example, at this point, we will know what is the particular round the particular round at this particular point. So even though the learning rate was set at the beginning to be, in this case, 001, maybe we could do some logic, like, for example, if server round is bigger than, let's say, 50, my learning rate is going to be a tenth, for instance, right? So this gives you a lot of flexibility to introduce, in this case, this kind of learning rate scheduling based on the point in time at which the experiment is at. But let's not do that. So, but maybe something else you might want to do is to tell the client, okay, what is the current round? Because maybe the client in that way will decide to do something in one way or a different way. But this is good enough for us now. All right, so this is one of the functions we wanted to define. The next function we want to define is one that will be used to specify how the client does, how the server evaluates the global model. So this is set through a function, through an argument called eval function. And if we look, for example, again on the strategy, let's go here, I have the Fed average open. What will happen is that the strategy at the end of a round will call this evaluate method. And if there is no evaluate function defined, then nothing will happen. We will return none. There is no let's say, centralized evaluation happening. But if you define a function, then that function will be executed. And you can see how it will be. So the parameter will be passing the parameters as a list of NumPy arrays, and that function should also expect to receive what is the current global round. So what we are going to define now is a function that has this particular signature. So 3 input arguments, server round, parameters, and a third argument, which is a configuration file again, just in case this has to be modified depending on which round we are at. So we can define this here in the same server script, and we're gonna follow again the similar logic. So this is gonna be a function called get evaluate fn, which we'll see what kind of arguments we need to pass very soon. And this is gonna return another function fn that we need to define. And we know that this function needs to be ready to accept these arguments. So one is going to be server round, it's going to be an integer, we have the parameters, which is going to be a list of numpy arrays, and then the last one is going to be a config, which is a dictionary. And well, if you look into this looks fairly similar to other methods we are already familiar with. Like for example, the client's fit, or the client's evaluate, even parameters and config. So obviously the first thing we need to do is to first be sure we have an instance of our global model, because remember, in the server there is not a PyTorch model living there. The only thing that is there is a parameters represented in a very FL framework agnostic way. In this case, we have them represented as numpy arrays. So what we need to do first is to instantiate the model. So let's see our model. It's going to be net, which, as we remember, it requires to pass the number of classes. So in order to be able to instantiate the model, we need to from model import net, and also we are going to import the test function, because we are going to evaluate this model. Okay, so where does this variable number classes will come from? Well, we can pass it directly from the main when we call this function. So num classes. Then we might, because the server is not part of the virtual client engine, therefore it's not part of the, strictly speaking, of the simulation. So there is not a sense of what resources the server will use. Is my simulation exposing the GPU to the experiment? Yes, no. And because of that, we might need to, well, we actually need to figure out what is the device that is available for the server process, which is the main process. And if you, for instance, don't want the server to have access to GPU at all, then you can specify that as an input argument from your main, for instance. All right, so now what we need to do is to follow a similar logic to what we did with these set parameters. Instead of copying the code again line by line, or type the code line by line, I'm just gonna copy this code here, which is perfectly valid for our example. So we know the model, we want to derive an ordered dictionary that can be passed in order to set the new state ticked of our model. So for that, we're going to do from collections import order ticked, and this looks pretty good. So now we have our PyTorch, standard PyTorch model using the weights from the server at this particular point in the experiment. And what we can do is to evaluate what's the performance of this model on a centralized dataset. In this particular case, we are going to use the test set that we have been keeping at a side here. So first things first, let's make sure we pass a test loader. And then what we're going to do is we're going to call this test function, which we need to pass the model, test loader, and then we need to pass the device as well. And this test function, if I remember correctly, is returning loss and accuracy. All right, and this will be, remember, the loss and accuracy of the global model at round, server round. So what we're going to do now is we're going to return this so the strategy can track what's the performance of the global model, and we're going to return following this style. Again, returning always the loss, and then any other metric. In this case, we only have the accuracy, so we are going to return only that. And if you have doubts, for instance, how this return function should look like, you can always go to the source code and you will see, oh, actually this function returns, oh, a single argument, but oh wait, it's 2 arguments. So the source code is always the best reference material, in my opinion. Okay, so now we are done with this. Let's double check in case we're missing anything. So we are not making use of the server round, but similarly to how I briefly presented the example of using the server round to modify one of the elements in the config, you could follow a similar logic to use the server round to change other aspects of how this evaluation is performed. For example, you could pass here part of your config and then tweak it based on the server round. That's, for instance, one way of doing it. Okay, let's save, and then what we're going to do is we're going to call this function, and the arguments we need to pass is the number of classes used to instantiate our model. I think it was like this, yes, and also the test loader. And this should be everything we need to define our strategy. So we can go ahead and run it and see if it actually is not going to run the experiment yet, but we can test to see if actually the strategy can be instantiated without errors. So let's clear this and let's run it. All right, so this tells us that the strategy was created, the strategy object was created successfully. Nothing has run yet, so we can only be sure if everything is working fine once we start the simulation, which is going to be the next step in our experiment.